Okay, so there's the number part 284c3m1b7c8e3f. Line 22f1fa19c3m1b7c8e3f. Tachyons, hydrogen, atomic energy, Cherenkov, UFO, 5G Wow Seti. There's our alien radio signal. This is a continuation of about 10 videos that are talking about powers that you can make with x-rays and crystals and stuff. So this is a keyword research from the previous video's data continues visible blue Doppler shift light. And DLS light was something else that we came up. And we have formulas after this. There's several formulas for this engine thing. So just so you know. So December 7th, I was doing the research. Today is December 25th. I googled the research keyword tachyons from the previous data video. Line 22f1fa19c3m1b7c8e3e. Bohr, hydrogen, electron, atomic formula, UFO, 5G Wow Seti. So that one has a formula in it. So that's the second formula we've come up with so far in this section. Actually, there's more than two, but in this series right here, there was a lot of keywords, so I broke them down into about 10 to 15 videos just for the keyword research, and then I also added formulas with those keywords as well. Things that we can try. Okay, so there's a keyword tachyon, quotes and diagrams from Wiki. A tachyon, or a tachyonic particle, is a hypothetical particle. Oh, so we got something to prove here. This is good. That always moves faster than light. So this is actually moves faster than light, and you were trying to get your neutrinos to go faster than light. So I wonder if neutrinos break down into these little guys, and that's what caused it to move faster than light. I don't know. We'll see. I know, if you don't get mad at me, I don't know. I'm just hypothetical here. Because the tachyon always moves faster than light, we cannot see it approaching. I wonder how they know that it moves faster. I'm sorry, but how do you know that? Obviously, I didn't research this enough. Or maybe I did. I don't know. I don't remember. So, quote from Wiki. After a tachyon has passed nearby, we would be able to see two images of it. Okay, so this is hypothetical. That's right. You guys think that this can happen. Okay, so after a tachyon has passed near... Sorry, it's first thing in the morning. I'm just half asleep. After a tachyon has passed nearby, we would be able to see two images of it, appearing and departing in opposite directions. The black line is the shock wave of Cherenkov radiation. So there's our black line there. Shown only in one moment of time. And I'm sorry, but this reminds me of the Messner effect. Okay. This double image effect is most prominent for an observer located directly in the path of a superluminal object. In this example, a sphere, shown in gray. Isn't that interesting? Because we were talking about building an obsidian glass sphere to use with the experiment. Cool, eh? The right-hand bluish shape is the image formed by the blue Doppler shifted light arriving at the observer. There's your blue. Who is located at the apex of the black Cherenkov lines from the sphere as it approaches. The left-hand reddish image, which is over yonder, there, is formed from red shifted light that leaves the sphere after it passes the observer. Because the object arrives before the light, the observer sees nothing until the sphere starts to pass the observer, after which the image as seen by the observer splits into two. Makes twins. One of the arriving sphere to the right and the one to the departing sphere to the left. Opposites attract, right? In special relativity, a faster-than-light particle would have space-like form momentum, in contrast to ordinary particles that have time-like form momentum. It would also have imaginary mass. Being constrained to the space-like portion of the energy momentum graph, it could not slow down to subliminal speeds. Mass. So I looked up mass. In a Lorentz invariant theory, the same formulas that apply to ordinary slower-than-light particles, sometimes called bradyons, in discussions of tachyons, that's why it came up, because I did tachyons, and then this came up with it, must also apply to tachyons. In particular, the energy momentum relation is E2 equals P2 C2 plus M2 C4. where p is the relativistic momentum of the radiant and m is its rest mass, should still apply along with the formula for the total energy of a particle, which is E equals mc squared divided by the square root of 1 minus v2 divided by c2. This equation shows that the total energy of a particle, radiant or tachyon, contains a contribution from its rest mass, the rest mass energy, and a contribution from its motion, the kinetic energy. When v is larger than c, the denominator in the equation for the energy is imaginary, as the value inside the square root is negative. Because the total energy must be real, the numerator must also be imaginary, i.e. the rest mass m must be imaginary as a pure imaginary number divided by another pure imaginary number and is a real number. So the key word is space-like for momentum from tachyon. I'm going to look at that in the next video. Okay, thanks for watching.